Alright, you are welcome back to Introductory Mathematical Analysis A. Introductory Mathematical Analysis A. And we are still in chapter 13, and again still in chapter 13.6, where we have application of maxima and minima. Applied maxima and minima. That is 13.6. Applied maxima and minima. Alright, we did some example in the previous video. Please check the previous video for some examples we did there. Now we are going to continue with some example. How do you bring out the function, the equation? Sometimes this type of problem we are dealing with in chapter 13.6. We have two parts to it. Number one, we give you the word problem, So you need to bring out the function and then you solve. You derive, don't forget, you bring out the function, then derive, and then test for minimum or maximum, and then get your answer. But sometimes they will give you, okay, that is second one. The second one, they will give you the function itself. They will give you the function given, and then you continue from that there. Okay, you continue from that there. Okay, so I think the most challenging part is when you are given the word problem and you are asked to bring the function and you are asked to solve that. That means you bring out the function first. That might be the most challenging part. Okay, please ensure that you are able to follow to know how to bring out the function. So let's read this again. A company annually produces and sell 10,000 units of a product. Okay, 10,000 units of a product. Sales are uniformly distributed throughout the year. The company wishes to determine the number of units to be manufactured in each production run in order to minimize the total annual setup cost and carrying cost. So we have two things. We have carrying cost, we have setup cost. Okay, so there are two costs now to minimize. The same number of units is produced in each run. The same number of units is produced in each run. This number is referred to as the economic lot size or the economic order quantity. Alright, the production cost of each unit is this. Production cost is this, and the carrying cost, insurance, interest, storage, etc. are estimated to be 10% of the value of the average inventory. Okay, 10% of the value of the average inventory. Alright. Setup cost per production run are $40. Find the economic lot size. Don't forget the economic lot is the number referred to the same number of units is produced in each run. This number is referred to as the economic lot size or economic order. Okay, all right. Now from this problem, what do you first notice? You first notice when they mention that our total annual setup cost and carrying cost. So we have two things. We have setup cost, we have carrying cost. Okay, so we have setup cost and we have carrying cost. So we have total cost. I can call it TC, setup cost plus carrying cost. Okay, setup cost plus carrying cost. Now the number is referred, the production cost of each unit is 20 and carrying costs are estimated. So our carrying costs are estimated to be 10% of the value of the average inventory. Okay, so let's deal with this one. Dealing with this one, it gives us 10% of the average inventory. 10% of the average inventory. That is, let's Q over 2. Okay, the average inventory. Okay, what is Q? I just mentioned Q without saying what is Q. Let Q be, I just say Q. It could be X also. We can make it X instead of Q. So let Q be the number of units. Let Q be the number of units in a production run. Okay, let's Q be, it could be X. You can make this to be X. So let Q be the number of units in a production run. Okay, so when I now say carrying cost from what we have here is now 10% multiplied by Q over 2, but it has a cost with it, which is 20. All right, so I multiply it times 20. Okay, times 20. Let me make this red so that I can later make that one a blue. So multiply by 20. Okay, so that is what we have there. So this one becomes 0.1 multiplied by this 10, multiplied by 10, multiplied by Q. So this just gives us Q. Okay, carrying cost just gives us Q. All right, so let's now go for this. In this one, we have that a company annually produces this unit of a product. Sales are uniformly distributed. So we can divide this 10,000 by Q because they are uniformly distributed. And the cost attached to that, the setup cost per production run is 40. So I can make this to be 40, that is the cost multiplied by 10,000 divided by Q, because they are uniformly distributed. Okay, so we are done. So to say, not yet totally done with the equation. So now this becomes 400,123 over Q. Okay, don't forget we are adding it plus, and then this one we solve this to give us Q. All right, so that is our total cost. Okay, that is our total cost. Okay, so total cost is given as this. So what do we do when we have this now? So don't forget we are minimized, so we find we derive first. We derive, so this T prime. Okay, let's derive first. This will become minus 400, 1, 2, 3, minus 2 plus 1. Okay, plus 1. We derive that first. Of course, we can write this again as this 400, 1, 2, 3. So what is the next thing? The next thing is to equate. Of course, this is still the same thing as over Q square. Okay, and of course it's still the same thing as this is now Q square minus 4, 1, 2, 3. Okay, that is that. Okay, that is fine. 10,000 times 4 times 40, 400,000. Okay, that's fine. All right, so we have that. With that now, we need to equate it to 0. That's the next thing to do. Equate this to 0. Okay, to get the value of our Q. So we have Q square minus 4 over Q square equals to 0. Okay. All right, with this now, what do? I'll get, this implies Q square minus this equals to 0. So q square equals to, alright, so what do? We find the square root of that one. But don't forget, we are taking only the positive side because we are dealing with an application, a real world problem. If you find this should be approximately this one, should be approximately this. Okay. Alright, now we need to find the critical values. What are the critical values? Critical values. Okay, before the critical values, let's check at what point will the derivative not exist. Okay, at q equals to 0, the derivative will not exist at q equals to 0. So our critical value is now q equals to 0 and 632.5. Alright, so we need to now, we are minimizing, we need to know test for relative minimum or relative maximum. Again, we can use either the first derivative test or the second derivative test. Okay, I go with the second again. Second derivative. So in the second derivative test, I just need to derive this the second time. I derive this the second time. Let me write the first of it. Okay, TC equals to 1 minus. I think that is what is there. Let me quickly check. Yeah, 400,000. Yeah. So if I derive this the second time, I will have TC because this will be 0, this will be minus or positive now. 800,123 q raised to power minus 3. Okay. Alright, please know how to derive properly. So this over q3. Okay, that is the second derivative. Now if you want to put each of these critical value there, again you will discover that TC of 0 will give us infinity, so we are not going with that. We don't need that. Okay, let's do the second one. TC of 63.2.5, I think so. 63.2, is it 63.2.5? Okay, that will give us 800 all over 63.2.5 raised to power 3. Okay, now from here, whatever the value you get, but what you will notice that is greater than 0. Because it's greater than 0, from the second derivative test, this gives a minimum. So q equals to 632.5 gives a relative minimum. Gives a relative minimum. Okay, since it gives a relative minimum there. Okay, so it gives a relative minimum. Alright. It gives a relative minimum. Alright. Let's go and see what other things did we miss in the question. Okay, setup cost per run and find the economic loss size. Okay, the economic loss size is the same number of units. So economic loss size is just this divided by Q. The same number of units is produced in each run. This number, yeah, so that is the economic loss size. So that's what they want us to find. So now the economic loss, since we discovered that this gives a minimum, so our economic loss size, so the economy size is 60. Okay, no, this is supposed to now be, we are supposed to have is 10,000 divided by, what did we get the other time? Okay, you divide that by that, which is now become, which becomes what? Which becomes if you multiply this, that is 10,000 divided by this. What is the answer now? Okay, 15.6. Okay, which is approximately 16 lots. Which is approximately 16 lots. Okay, which is approximately 16 lots. So we have that, and that is what we are looking for. Please ensure that you understand. Ensure that you understand. Let me see if I miss out anything. This number is referred to as the economic lot size or economic order quantity. Okay, that's fine. The production cost of each is this and this and this and this. The same number. Okay, that's fine. You can leave it as that. Okay. All right. So please don't forget how we get all that. We need first to find the equation or the function. You need to find the function first. I told you that might be a challenging part of this session 13.6. You need to find the equation first, and then after finding the equation, you just follow through with what you have done before, with deriving, equating the derivative to 0, finding the minimum or maximum, and then test for relative maximum or minimum by first derivative test or the second derivative test, and then put it back, or finding the minimum value or the maximum value as they want you to do. All right. Okay, that is it. That is what we have done. That's what we have done. Okay, let's go into this again. Now, another example, an article in a sociology journal stated that if a particular healthcare program for the elderly were initiated, then 3 years after it starts, 10,000 elderly people would receive direct benefit. Where, so they gave us the equation here. For what value of t does the maximum number receive benefit? For what value of t does the maximum number receive benefit? Okay, you will notice here they gave us the function already, and then the interval is in a closed interval. Please take note of that. This is the same thing as this one. You can write this as this. Okay, it's the same thing. It's the same thing. Now, in a closed interval, you remember when we say in a closed interval, we're going to get maximum there, we're going to get minimum there. But they want us to find what value of t for what value of t does the maximum number receive benefit. So they want us to pick the maximum there. Okay, but this is a closed interval, so we use the extreme absolute value theorem to solve this problem. Okay, but the first thing again is that we need to derive. So deriving n now, deriving this, we have 3 over 3 again, t squared minus, derive this, 12t plus 32. Okay, that is the derivative of that. Of course, this can be written in a nice way, t squared minus 12t plus 32. All right, so what is the next thing to do? The next thing is to equate the derivative to 0. Equate the derivative to 0. So we have t squared minus 12t plus 32 equals to 0. Okay, if you factorize this, you should be having t minus 4, t minus 8 equals to 0. Let's test t, 12, 10, 32. Yeah, that's fine. So that means t equals to 4 or t equals to 8. All right, that is it. That is it. So t equals to 4. What is the end point? The end point is 0 and 12. So t equals to 4 and t equals to 8 is within that interval. So it's fine. So the next thing to do in this one is just to evaluate this function at this endpoint and at these critical values. Okay, of course, the critical value for these critical values are t equals to 4 and 8. Those are critical values. So we just need to evaluate. Don't forget, we just need to evaluate. There's no need to be finding the second derivative or using the first derivative test. No, there's no need to do so. So we just evaluate. So now we evaluate t nt. We just evaluate this nt. Okay, 3 square. Okay, so I have my n. I write my n again. N of t equals to t3 over 3 minus ct square plus 32t. Okay, so I need to evaluate this at 4. So that will be 3 over 3 minus 6 4 square plus 32 4. Okay, you can press your calculator on this. Okay, if you press your calculator, that should be giving us over 3. Okay, I need to also evaluate it at 8. N of 8, that means 8 3 over 3 minus 6 8 2 plus 32 8. Again, at that point, that is, I will be getting 128 over 3. Okay, that's fine. Then at the point, at the end point, this 0, so it will become 3 over 3 minus 6 of 0 plus 32 of 0. Okay, you can see that this one is just 0 0. All right, so this gives us 0. Now at 12, okay, don't forget the endpoint is 0 and 12. So we evaluate it at each of these critical values and at the endpoint. Okay, all right, that will give us, what would that give us now? This gives us 12 3 over 12 3, not 12 13. 12 3 over 3 minus 6 of 12 plus 32 of 12. Okay, what that will give us, that should give us 96. Okay, now what is the maximum? They want how many of this, which one of these will give us the maximum? So we can see this is 96, this is 0, this is 128 over 3, that will be 42 point something. So that is, this will be 50 something, 53 point something. Okay, all right, so the one is this. So the absolute maximum, so the absolute maximum occurs at t equals to 12. T equals to 12, and the maximum value will be, and the maximum value is 96. Yeah, okay, all right, please ensure that you understand. Okay, that is all what you have done. Please ensure that you understand. Thank you.